I guess we're going to jump into the next topic with you, Fabian, the security misconfiguration and XML entities.
Yeah, I'm taking the external entities, and I think it might be a good idea to put that in now.
Okay.
Would fit well.
Take it away.
Sure. I'm sharing my screen. Nicely visible. Great. Okay.
Yep.
So XML external entities, for those who have been on the security training before, it was always a little bit of a frustrating topic because I was like, hey, this security thing exists, but kind of it has been mitigated everywhere, and by now it's not a big problem anymore. And I was telling you some best practices on how to mitigate it, but it was really frustrating because there was really no danger felt from this thing. And that felt wrong because it's still in like the top thing and has been a huge deal in like 2014 or so, but it can still be a problem today, especially if using, for example, PHP. And today I'm very proud and glad to be able to show you an example of how some simple mistakes that can happen as part of not adhering to some code standards or just of misunderstanding something can lead to this problem of suddenly appearing again. So let's start. What we here have is, first of all, we start with the harmless XML. Let's understand a little bit of how XML works. With XML, you have like this header, then you have the doc type, and this doc type, which is like a DTD, it can contain entities, and this entity harmless is completely harmless. And the result is, this result is and harmless. So if you know HTML, you know this like and non-breaking space and greater than or whatever, and that is already an entity with an XML. But by specifying the DTD, we can define as many entities as we want. So this is essentially a reference to something else that is defined here. And the advantage obviously is reuse. We just need to write completely harmless once. We don't need to do it several times. So how can we load this? Let's just go to the next example. We just call simple XML load file, harmless XML, and we're printing it out. So let's do that. And as expected, this result is completely harmless. So now how could some harmful XML look? That's the first thing we need to understand. And the first thing that came to mind is to just use an entity, and use the system command, and then you reference to a file. The huge problem with that is that if you're referencing to a file, the XML parser will say, hey, if I put in the string etc password here, it's not valid XML, it's not even valid text. So this will fail to do our exploit. I'm not going to go into that in more detail, but it fails. But fortunately or unfortunately, PHP has a nice way of making this work. And this was actually almost exploited at Facebook. A security researcher found it before any malicious hackers, is assumed, and got a nice bounty for it. But essentially, this harmless entity is no longer, definitely not as harmless anymore, because it's referencing to some different system. And this is using PHP's file loader to essentially the streaming, where you can have like in Drupal, we have public, we have private, but there's also PHP. And PHP has a filter function, and so I can easily read the resource of etc passwd and automatically convert it to base 64 encode. The point, however, is to really make this work, this harmful, is that we need to actually do something very special. We need to put this very special parameter lick.xml no end. And this was what I was saying is, yeah, by now if you're just doing this, like if we were removing this, like real quick, and we're just outputting that, and we're just outputting the XML from that, and not the basic code, then yeah, there's nothing here. But as soon as we allow like this libxml now end, then our exploits start working, and as we can see, we call the XML harmful.php again, and here's our etc password. Okay, so someone needs to really go out of their way to shoot themselves into the foot. But because of the history of the issue, there are also valid ways of why this might be needed. So, for example, if you're using a SOAP client or you're using some very special XML from some external system which is completely trusted, and where you definitely want to load external entities. So there's a valid use case for that. So some code could still have that. And this is essentially what happens here in our scenario. I've created a little library, and this my lib.php is really simple. We have an init function, and because those people had been really security conscious, they disabled the entity loader by default till the XML2 has been fixed. So there's even a nice comment about it. Here we are loading the libxml no end, and whenever someone within the old code, like let's assume this from another project, needed to get some entity from a trusted system, they would just disable the entity loader to false, allow entity loading, load the entity, and disable it afterwards again. Always secure, nice, and extra code. But now this whole library is given to another developer who's also developing something, and they want to use this library, and so they'll be using this library, and actually they init, load the XML, harmless XML, and putting it out. Again, we can test this, and we see okay, we can't even load this file. So file loading failed, so we remove the init because we're a nice developer, and hey, it works. Okay, not so nice. So our developer might have just thought, hey, this init function really does not do much, let's just remove it, and my code works, I have a deadline to keep, etc. like that. As I said, very bad practice, but it can happen in practice. And well, or the developer could just forget, like myself. When I was writing the sample code, I was like, hey, that's why this example fails, by the way, is, hey, I could just not init the library because nothing forces me to. So again, might be a little bit more of insecure design, that if you have a library whose init is not mandatory, like in a class constructor or something, people could just forget. And if there's no notice of, hey, you haven't inited this library yet, it's not safe to use it, things like that can happen. So again, we can just, yeah. And the thing is, however, we have a harmful result as well. And again, we would need to quickly remove the init code. Yep. And then it would fail. I think that, yep, here we have it. We init the code, and we can make it fail, and all this garbage is again the etc password. Okay, so, but let's say our developer isn't so junior or negligent of just saying, hey, I'm just gonna remove the init. No, they are like, I need my code to work. Let's figure out why this library that should supposedly be so great and that I've been told to use is not working. So we go into my lib again, and we look at the code, and now we find, hey, it's probably this line that makes it work. But here says till libxml2 has this fixed. But if we now were looking at the PHP documentation for the disable entity loading, what we would actually be seeing is that this has been disabled. So PHP has this little sentence here: as of libxml 2.0, entity substitution is disabled by default, so there's no need to disable the loading of external entities unless there's a need to resolve internal entity references. Well, okay, so it's disabled, and we can say, let's just remove it. And I have already prepared that, and here I want to show something else which is really important in terms of that. Let's take a look at the log of import lib fixed. And as you can see, it's only the import of mylib from project foo. It happened to me more times on various projects in my whole future, not necessarily at Tech One, but especially also at clients before, that people have presented me PRs where there's a completely innocent import of a mylib, but the code has been changed. What I would like to see is at least this, because now I at least see here's the import of the mylib as unchanged, and now it has enabled this loading. But still, if we look at this as a code here and checking this, I might still not spot this as a security problem. I might, but others might not. It can fish through, and if we again look at the whole diff of that thing, and if someone isn't looking at the individual commits when reviewing this code, again, this could just fit through. But again, our developer is happy. Let's check out main. Everything is fixed. And so now all our examples are working. It's harmless, and it's broken. So, and what I did here is I was loading this payload just from a gist where I've uploaded the XE. And obviously there are several ways to solve this problem. The easiest way probably would have been for the developer to just not load a file, but instead just load a string, simple XML load string. The other is to obviously not have such dangerous functions in the library, like never do this libxml no end. And what my critic has been and still is that this is just named really bad. Because if it says no end, I assume it disables something. I would never come to the conclusion that this is enabling something. So yeah, this is very, very misleading. There's a huge security notice on the PHP website, but if you don't look at it and just assume this is doing, like it's disabling external entities to be loaded, then you will think this code is valid, but it's not. A way to solve that whole thing and to get much control about it is added newly to PHP 7 and mandatory in PHP 8, and that is to set an external entity loader. That means we can decide what happens if we get such a request. So again, here I'm loading my bad example, and we replace even the file loading already with our great example. But now it's completely harmless, but if I replace this through the harmful.xml, oh yeah, the end here harmless is not defined. So I would need to do a little bit more to get this to work now. But for example, if I just made it do this public, which is probably what I want, then it should just maybe work or not. Anyway, you can play around with such a loader, and oh, it's not public, it's the other one, it's system, obviously. Sorry, live demos have risk. And there we are. there's our payload again. So we've now replaced the anti-loader through the default anti-loader, but we can clearly see that here's this PHP coming in, and we could prevent it from ever reading something that has PHP as a file or anything that's not trusted. I could validate all URLs that are going through that they're coming from trusted systems, and now have full control, even though for some valid use cases I need XML anti-loading. So for that library, a good design would probably to implement a class, have the constructor do the initting and setting this external entity library loader, then have a whitelist of things that are enabled, and then ensure that someone is using it. Or a much easier way, just have two functions. One function for loading XML with external entities, which is clearly defined as that, and one function which is harmless, which you cannot shoot yourself in the foot. Yep. And that would be it for external entities. That's what I said. Never ever put this XML no end on a helper function or something like that. An example of how it can also happen in Drupal is several input filters in Contrib and even core are implemented by loading strings via like simple XML load file or simple XML load string. And if some of them were using like a vulnerable XML version on some very old server, or they were explicitly passing this no end because they are completely confused on what it actually means and they want to make it more secure and just mix it up, which I think even happened in some Contrib code at some point. Then this input filter would mean that an editor just would need to put an XML document inside of what you see is what you get if they have full HTML, and they could take over a site essentially where another remote procedure exploit call, for example. Like you could then download settings PHP because the file, the editor with not many permissions would be editing the XML, would then show the Drupal settings PHP, and then they have the credentials for database and everything else and things like that.
What about if we were using, I assume this vulnerability would also affect any, potentially any HTML templating as well, if we're doing like HTML to PDF generation? You think that would also be a vector here?
Yeah, as I said, you need to shoot yourselves in the foot by enabling the external anti-loading right now, so it's a little bit more unlikely unless you use some like helper function or library is completely broken. But yes, in theory it can happen. If you load a string and it's a subpart of that, and that node happens to be valid XML and HTML, and it just gets, in theory, if someone is hiding an XML document somewhere and you are extracting that and then putting it back to a string and then transferring it back into a DOM document, it could trigger this exploit. So just be very, very careful in never using XML no end, and general be careful of what data you have. Validate data, like for example, if you validate that it's valid HTML, then most XML documents would fail that validation. Things like that are very good. Yep, thanks.
Yes, so the topic that Fabian just covered is part of the security misconfiguration category. And there are other things that we can do wrong when it comes to configuration. We obviously have things like this is multi-layer topic. Configuration can be about the application configuration. It can be also about PHP language configuration, but it also relates to infrastructure and the operating system. So we have to think about all those layers. And some recommendations or best practices that I would mention here is first to use the approach to deny by default and then selectively grant access. Think about your features and services and consider if you really need everything that you think you need, and disable things that you can live without, because every single service that runs on your system, or every single port that is open, or if we're in context of Drupal, every single module that we install or page that we create, adds another possible attack vector, theoretically. So if we have less things and more simple system, it's less likely that something will happen. It's also easier to reason about the system and to understand it and to know what is going on. So always try to keep things stupid and simple. In Drupal specific projects, but also more in general, things that we can do is, first we can follow and learn about best practices about the system that we're using. Then one thing that we can do is making sure that no folders are exposed to the world that are not intended to be exposed. Example of those would be, for example, .git folder. If you expose .git folder, you potentially expose your entire code base to public, which is definitely a bad idea. Another thing that is Drupal related, but could also apply to other frameworks, is the configuration files. If you put your configuration files into doc_root, and I believe that, I'm sure that before that was the case, but it might still be, I'm not sure. Drupal put configuration files into public directory. There might be that there was an HD access that was preventing listing those, but you can easily, accidentally remove that HD access. So the best practice in Drupal definitely is to move your configuration files outside of the doc_root. And this is exactly what the default composer project will do. And we should use that instead of trying to figure out our own way of doing things. Same goes with private files or the vendor directory. Like everything that doesn't need to be visible to the public should be outside of the doc_root. Another thing that can happen is like that you have unnecessary modules enabled. Maybe you've enabled some modules that helped you do some one-off task, but then you forgot to disable it. And maybe that module has some page that exposes some information that you don't intend to, or something like that. So something to be very careful about. Then we have superpower users. In Drupal, the example would be the user with user ID 1. But there are other things that we can think about. For example, root user on Linux operating systems. The best thing to do is just to disable them. Like we never use the UID1 account on our projects that we work on. It's always disabled, and then we use actual accounts for each user that needs to access it, even if we're talking about administrators that have defined permission sets instead of having access to everything like that super user has. With root user on Linux, the example would be to denying access through SSH for that user. Most modern distros, this is already done, but something to think about. Then a lot of times there would be issues with file permissions on the server, like having PHP files writable, settings PHP write, all those things. And I would say the best way to avoid those kind of issues is to automate deploys and never manually change things. We've all been there where we had a problem, and in an environment where automated deploys are not strictly enforced, somebody went in, logged onto the server, and started messing around and trying to fix things or tried to figure out what's going on, and along the way changed permissions to some files or something like that, or manually changed the file, and then forgot to revert it back. And if we have automated deploys, we can have steps in the deployment that make sure that all these things are set correctly. And if we enforce these automated deploys, then there's no way that somebody can go in and manually change things. So definitely best practice. Yeah. Then also think about the configuration of your web server. Think about security headers. Are the security headers set correctly, sent correctly? We're talking about like HSTS header, course headers, things like that. Do you have any other comment about this topic, Fabian?
No, I'm good. Yeah, as I said, again, it's important to just follow the best practices. I think that's the only thing you really need to say to that of the security misconfiguration. But again, even my example of the XML external entities, the practical example, was kind of a security misconfiguration bug here. One thing that, by the way, could have happened much more catastrophically is, let's assume this library finds its way upstream again, like this update of removing this because it's no longer needed, and no one is reviewing it, and now it ends up in a completely different production application that had been very secure before. And suddenly this application gets vulnerable due to this library having changed to be something insecure suddenly. And I think that's an important part of how to think about security misconfiguration, that some misconfiguration somewhere, or using a library wrongly, or enabling something that shouldn't be there, can open huge holes in completely unrelated systems. That's probably also what happened like with the log4j thing, if you are aware of that vulnerability that we recently had, that whenever something was logging something, it could lead to an exploit. But that means if there was some server sitting in some in the end of the room that no one even knows about anymore, that is for some of the reason also going through log files, then that's a huge problem, because it might be misconfigured because it has still the old log4j version, for example, and then suddenly you get an exploit even though your whole system is completely firewalled, etc. like that. So, but yeah, whatever is processing data needs to be securely configured. I think that's kind of the rule of thumb here.
Are there any comments or questions about this topic?
Awesome. Thanks, guys. Fabian, next up is server-side request forgery.
Sure. One moment, I'm gonna. Oh, Janez, can you open that on the screen already? Yeah. I always like to think of packages as liabilities. So every new dependency is also adding a liability, and then it's much easier to justify things like that. For example, yes, there's certain ways where custom code, like if you write like 5 lines of custom code, hey, better than to just add another Drupal module or library or whatever. That is indeed better. But if you have very complex needs or are in security critical ways, then it's often better to just use established libraries. I think one important thing is, however, to understand the distinction between concepts and code of libraries you're using, and also of why you are using them. So sometimes modules or libraries are just added because of, and that's not always a good idea. We see the extreme of that in the npm and Node ecosystems, where like there's sometimes like one-liners shared as libraries that everyone is importing then, etc., and leads to these huge dependency trees. And while an ecosystem of many libraries has its advantages as well, one problem of not having a framework like that's more consistent in everything, like Symfony or Drupal or whatever, is that you need to trust a lot more people. Like with Drupal, you need to trust Drupal and mostly Symfony, and Drupal even takes a little bit care of the Symfony and other dependencies, for example archive tar, that they are remaining secure. But if you're just using whatever library someone has, it can be of limited quality, or with jQuery, for example, there's a problem that maintainers go away or don't want to maintain old versions anymore. Or archive tar, by the way, it's a good example. It's used by many large frameworks. It's on peer, like it's a PHP core thing, but they had a security incident that was handled a little bit poorly, I would say. So it always depends on how good the backing is behind those things, and that's one of the advantages of larger frameworks, larger islands that are behind something, larger projects that are well backed and have strong developers behind them, because they often are a little bit more professional than, or you need to do a little bit less due diligence than if you have those other things.